Hey everybody, this is Larry. This is Leetcode Weekly Contest 436. Hit the like button, hit the subscribe button, join me on Discord, let me know what you think about this contest. I just woke up from a nap, so I'm a little bit trying to collect myself, but we have 40 seconds to go, so we'll be good. We'll have fun. It's fun. It's fine. Yeah, I hope everyone's having a good contest or whatever. This is a live recording of just me doing the contest. If you're looking for explanation and so forth, well, I mean, just YouTube search for the problem name, you'll see it, but it's also in the description, so you could go through it that way as well. Yeah, wish me good luck, even though, you know, it already happened by the time you watch this. But yeah, let's go. 6, 5, 4, 3, 2, 1. Go, go, go. What does that mean? The middle diagonal. The diagonals are what? Oh, I see. That's weird, but okay. That's a Q1. I mean, it's not that bad. It's just easy to get wrong. That's all. Yeah. Okay. We want to do. Nope, it's x minus y, right? Then now, okay, so we sort them. Let's convert them to deck. Okay. Okay, so if x minus y is 0, x is greater than y is from the bottom, then we want something like that. Nope, very well. Is it the other way? Oh yeah, I meant it's the other way, I think. Yeah, 823 967 451. Okay. Okay, really annoying Q1, but not too bad. Focus. All right, let's go. Whew. Groups. I'm gonna check. so confused. I don't even know what it's asking for. Zero, 1, and 4. Okay. This is so confusing. Okay, so 4. So n times year is going to be too slow. I guess that's the kick, right? Okay, so then we in theory it's just loop spit. I mean, I know it's just ultra-McCoy, but it's kind of hard for a Q2, huh? Am I confused about this poem? Maybe, huh? I guess, am I just thinking of a dumb way? I don't know. Maybe this will time out and I'm being dumb, but I don't know. Maybe I am thinking of a dumb way, but yeah, I don't know. This is such a crazy way to do it, though. Yeah, I don't know. Is this fast enough? Honestly, not sure. Because it depends on their input. It's a little bit. I mean, I know it's m log m, but wow, 2 hearts. Did anyone get this one? No. Okay. Still, what a weird problem. Alright, let's go. Okay. I don't know how to do this one. But it's substring or sub the n square. How do I want to do it? Contribution, of course, but there's only 10 digits, right? So that's fine. Yeah, okay, that's not bad. I got it. Probably, hopefully. Okay, so shift and add, shift and add. Well, I guess it starts at 1. Shift and add x or over sub I, shift and add. Now you need the mod, I know. Okay, fine. Right, so if x is not equal to 0, no, this isn't right. It's kind of right, but it's not right. What am I doing? I'm missing a piece. Okay. What I want is, let's say right? Is this, but I'm missing one thing. I had in my head, but I forgot. No, you have to keep track of the count, not just the mod. Is this times another 10? But is that right? No. We could do it for every 10 digit, right? So that's not that big of a deal. Yeah, okay. No, but that's 10, that's 100 times 10, that's too slow. 10 million? Is it too slow? Maybe it's only too slow in Python. Okay, focus on getting it right first, and then we'll convert it to Java if necessary. That feels right though. 10 million feels right. Okay, fine. Yeah, okay, that feels right. Okay, yeah, fine. Okay, and then now we want to say, okay, and every previous number no, the I doesn't exist. Every previous number we shift the new R I see. So new R is equal to and then new R sub J is equal to how many we had previously. So this is J times I plus X mod I. So this is the number of new R, and then new R of X increment by 1. And then now, if X is equal to I, then count to X, no, R of 0. And also X is X mod I, which is actually important for some stuff. I don't know. For one, I think it's the key part. And then after that, R is equal to NR. I think this is actually NR, but fine. Someone like this. I think it may be too slow for because Leetcode is silly. Okay, it's not right. It's right for the last one, so that's good. I was only thinking of 1s and 0s, so maybe there's something weird about it. Okay, so here. So for 1, it only has one number to end, so 1 has 1. So we have 6, we want 11. So it's undercounting. 2 is 1 and 2, so that's also only one number, 1, 2, and 2 and 1. 12 and 2. Okay. 3. 3 is 1, 2, 2. 11, 15, 4 times 3 is, or 5 times 4 is 5 times 6. 5, 4, 3, 2, 1, 5 times 6. Okay, fine. But okay, so 3 only has 2. Okay, so it's 3. It only has 1. It definitely has at least 2, so that's wrong. Let's start at 0. Okay, so I feel like I think this is right-ish, but I'm clearly wrong here. So 3, 1, okay. 12, shift and add. So this is a 1 times. Oh no, this isn't. It's not times I. It's times 10. Okay. 10, 12, 25. Am I right? Nope. But closer. Maybe. Okay. Okay, this is just wrong because... No, this is right. Whoops. Is 2 is going to be 3, so that's right. So 3, we want 1, 1, 2, 9. Four. No, so that should be 3, which is right. Right, because it's one represents 223. Yeah, no, that's right. And then 6. No, this is 9. Represents 9. 9 should not have... Oh, am I dumb? Oh, no. This is represents 3. So 3 has 3 is right. But then 9 only has 1, which is probably right. No, it should be none. So that's not right. 9, Oh, no, it should have 1 because of itself. 29 is not, so okay, so that's 10, okay. 9 has 1. 6 has 4. So 6 has 4, but that's 3 because... Well, I mean, I don't know. 1, 2. So this is the 1. Well, this is undercounting because it should always have. Yeah, these numbers are just wrong. It should always have more number, not... Oh, whoops. What a silly mistake. Okay, 11, 18, 25, that's right. What a silly mistake. Okay. Oh man, I don't know how DP anymore. Okay, but then now what we want is if S is equal to some long number. Is that fast enough? 1.8 seconds. I'm not confident about it, so I'm going to convert it to Java. Because this is very silly to write in Java anyway. Well, not silly as in like in a good way. I'm not confident about it in Python. I have to ask it to pre-calculate the numeric conversion because it looked kind of wonky. I don't know how to copy this. Also it converted to int. So I have to convert it to using long. Okay. Paying the paying the Python tax right now. Yeah, I don't know. It's still kind of slow, honestly. I don't know how much of it is just this thing. Okay, let's YOLO. If it times out, it times out. Is this long? Int should be... No, I mean, I think technically it fits. Oh, no, this is fine. Actually, this is for this, not that. Alright, am I confident? Not really, but let's go, YOLO. Okay. Well, not bad. How many people got it? 63. And 1 people got Q4. I got that one much faster, but Python things, I don't know. Let's see what I mean, let's see what I've gotten it in Python. Maybe I should wait till the end, but I just want to also YOLO submit it a little bit. Yeah, Python seems like maybe it would have timed out, or at least be cutting it really close. Okay, so I don't know. So really not confident. It's not worth the gamble, I think. Anyway, okay, so we have an hour and 4 minutes left. Okay, game score of length n. There's another. Oh, what does this mean? Oh, the game score changes, so we have 2 games. Okay, I'm still not. I don't even know what this is saying, but okay. Start index -1, which also m moves. At each move, you can add 1, increase it by 1, and add points up to the game score. Decrease the index by -1. So you always have to start at the first move. That's a really awkward way of phrasing it, but after most m moves. Okay, so here we go to the 2, and then we go to the 4, and then 1 more move, we go to the 4, we increase, and then we're done. Okay, fine. 1, 2, 5, we go 1. Okay, I mean, this is actually a good example. Thanks, Leetcode, for actually putting some effort here. The score is 2, okay. Okay, I mean, I think I understand it, but how do I do it? I don't know. And m is 10 to the 9, so you have to be a little bit smarter than that. I mean, yeah, I'm a little bit smarter than something. Okay, so what does having m mean? You don't have to go anywhere, right? So, but you have to get the, you have to maximize the minimum. So then the question is, okay, let's say we have a binary search. What would that look like in terms of moves? That means that, okay, so let's say minimum moves, then we want to do 2. But how do you do the check? The check should be simple, maybe. It just, okay, so let's say do, right? So then we just go if it's possible. This is 7 point. Is it true? Some stuff. No. One, right? 3. 1, 2, 1. So okay, let's just write it out real quick. 1, 1, and 2, 1. Okay. 2, 2, 3, 2. Okay, 3, 2, and then otherwise it's 3, 3. So okay, fine, right? Then it could go 3, 3, 1, 3, 4, 1, 3, 4, 2, right? 3, 4, 3, 3, 5, 3. I mean, that's it. I think. I mean, it's gonna be binary search, but how do you do the satisfactory? How do you check whether a thing is possible? Okay, 354. 354. Okay, so that's possible. And then 3541, 35411, 541 or 21. 35521 is possible. Then in that way you would go 33. So then 2. Okay, what does 33 mean? Okay, 1 1 1 1 1 1 1 1 1, right? So then you have 2 4 2 1, yeah, 2 2 1 1, which is possible, I suppose. What if you have 5? Is 5 3 1 possible? No. 5 4 1 possible? So we have a number that is bigger than the next number, then it has to come back, right? What's it equals to do? Yeah, so then it has to come back. Okay, then it has to come back, right? This was so good. I don't. Then it would have to come back, right? Because basically, if you have 6 3 1 as a requirement, well, you can always just put extra values. Six 5 1 possible. 1 1 2 2 3 3 4 5 5. And then 1. So no, 6 5 1 is not possible. But 6 5 is possible. Because then you only have one case where this is true, I suppose. And only by one. I think, I don't know if I could prove that though, honestly. So, okay. Was it 10 to the 9? What is M? M is 10 to 9 moves. So 10 to the 15 is fine, right? 16. Okay, so this is possible, then we want to try a bigger number, right? Okay. Yeah, still very fuzzy to me, honestly. I think the idea is roughly right, but I don't know that I'm very precise. I probably don't need this, but I think it's easier for me this way, but I guess I could just do this. I think actually this is slightly faster, and I think I need the speed actually. Otherwise, okay, so if need of I is, this is normal, right? Okay. Fine. Otherwise, what happens if it's? I think if, even if it's equal to is fine. It's only when it's not that's the tricky part, right? Remember, you can always go over. So okay, so if this is not, then there are only two possibilities. That's an annoying thing. If the previous number is bigger. Then we want to set add is equal to n minus 1 minus 1 can do 6 5 5 5 right? 5 5 1 is not fine, but then what? 6 6 1 is fine. But 6 5 but 6 5 3 is still not fine. Really? But that means that you have to add it to it. I don't know how to do this part. Huh. The idea I think is roughly right, but I don't know how to check this. Do I need to do DP maybe? Or add it and not add it? Maybe this part has a linear DP. Okay, so let's try. We have 631, then this has to be at least a 5, right? So okay. So add right? Add turns we add. Okay. Just so that we have enough turnarounds. Right? If last extra is not none, then we need to add one more to that one so that you go flip it forward. Right? Okay. So then if last extra is equal to I, it doesn't really actually matter. But then that just means that turns add 1. Right? And then now also technically and needs of I is equal to 0. Because this does not satisfied anymore. Yeah, whatever. And then the last one, we want to add it again because anything we have left over, we need to do it, right? Something like this, though, I don't know. This feels a little bit wonky for sure. And it's not going to be even a good answer for this one, but that's okay. It's just returning good for everything. I don't know. Turns is 2. Why? Did I do it backwards? Target. Is it over target? No, it's the other way around. You dumbo. Yeah, though actually surprisingly that part is right. Okay, 2, 1. Alright, not right, but that's okay. At least it's slightly more right than the previous one. Okay, so you have 2. This feels wrong. Oh no, because it's not at the beginning. Okay. Okay, so you need this feels weird though. 2. Okay, so first it tries to see if we can get the score to 4. Oh, the answer should be 4, 2. I'm doing 2, 1. Okay, so the 4. Okay. Target turns is 4. Why does it take 4? Because it's 2, 1. It thinks it's 2, 1. And then 2, 1. is this part, and then it tries to get to 1, turn to 0. Oh no, this is add minus need sub I. Could also be, it should not be, by definition this should be at most 0, but we'll see. 4, 2, okay. I don't think this is right, honestly, but it is right enough for the inputs, which it's good enough for me to YOLO. To get a wrong answer so I could kind of see how to fix it. Actually, one's longer than expected, but it's just probably a long time to get a wrong answer because it does like some silly checks or something. But like I didn't expect this to be right, frankly, but I don't think I have any other ideas, so I did want to see it. But okay, so this is kind of good in that maybe there's a refinement thing, but oh, is it a binary searchable then in this case? No, it should be because it does not. Yeah, no, it should be a monotonically increasing function. Okay, fine. Okay, so 71 takes 30 turns, maybe. I don't know if that's true. But 66 takes 26 turns. That's maybe wrong, because the matrix is 3, 7, 10. So then now 3 turns, so then it's 0, 4, 10. Okay, and then now for 0, 6. So that means that it does that's 14 moves plus 12, show me 26. Let me also just for reference. That's the right answer. It's not me just putting in random 69 for a random reason. 69 is also 26 by my calculations. Same as 66 actually, but oh, wait, is that true? Is this minus 1 because you can't, wait? Okay, so there's some parity thing here, maybe. Okay, so 4. Wait, we're at 3, 3. So we're here, right? This isn't quite right because of the parity thing. I expected a lot of, like, how many wrong answers did people get on this one? On the top people? Okay, good amount. Some people with a lot actually, but because in theory it should be just 5 plus 6 and not 6 plus 6 here, but I don't have. Oh, because it is on the odd, so you can't really do it the way that I'm doing it. Can ya? Because if it's 0006, then actually you can, because technically you start 1, 2, 3, 2, 3, 4. No, I think that's right. I think this. Okay, I see. Maybe. Okay, so if need minus 1 is greater than 0, then we add it. But if last extra is none, then need something like that, maybe. Yeah, 40. I don't know if this is right still. but and a random 69. But like I said, I'm gonna keep YOLOing because I don't know. I feel like the idea, like the general framework, I think is right, or the idea is in the right direction, but clearly it's not right enough. And I don't know how to, and maybe it's not, honestly, but I think it's something similar. I think there is something about parody that I'm not handling. I'm just kind of trying to see if this hack fixes, but I'm not super confident about it, clearly. Yeah, okay. We have 4, 2, and 9. So I'm giving too good of an answer. Okay, so 2, 2, 2, 2, we have 2. Okay, so if the score is 8, then you have 2, 4, right? Take 7, so this is clearly good. 10, it thinks it's 9. Why? Because it does 3, 5, which is same as 2, 4, but the parity is right. And now you have there's some like one funky thing here. Because we haven't used this yet. Okay, so this is where this thing broke down, actually. So this logic is not good enough for this one. It matters what the parity is. It matters what the parity is for this last extra thing. Because it all... Maybe there's a more direct framework that I'm not understanding. How do you check if you can sneak back and forth? In the minimum number of moves. So okay, so let's say these are the requirements. Maybe I can do a DP instead. There is this odd even parity that I'm not handling right. Because okay, so let's say we have 3, 5, and that's wrong. Okay, fine. But then what we have 3, 5, 3. We do 3, 2, 3. But then you're here, so you go here. That's 2, 1, 2, 1, 1, 0, 0. So 3, 5, 3, or 2, 3, but with a parity offset of 1. Is there a better way to think about this? Whoops. Notebook on the keyboard. I feel like I got 2 wrong answers, that's fine, but people got getting it though. Really quickly, actually. how else do I think about it? Everything else, the framework is fine, maybe, but so how many moves is 3, 5? Oops, 3, 5. It's gonna be just 10, right? Which does not take advantage of the last extra which I put in here, which doesn't really make sense, honestly. But well, it makes sense if it is odd or something. But I don't want to try that again. But like, so I could write something like that, but that would fix that. But I don't think that's right, because then now you just, you know, this doesn't do anything. I want to add. There's something weird like this. I have to handle the. I don't know how a consistent way of handling parity. Okay, so let's just say we look at the pairs, right? Okay, fine. So we can, for every pair we can subtract by the min. Then now we have these islands or whatever of leftovers. I think the last extra stuff is just weird. Everything else is kind of roughly right, but the last extra stuff is a little bit awkward. But this is going to give me not enough of an answer, because it thinks that I'm making too many moves. For 4 we have 2, 1. We think it needs 4 moves, 2, 1. Is there a DP? Minimum number of moves that fits these things? Carry one over, maybe? I don't know. I don't even have an idea, honestly. Well, I mean, I was hacking some things together, and I think that it's generally right, but I'm missing one thing. I mean, it may not be greedy, but I'm missing one way of solving it. Can I do DP? Okay, so how do I do like one, two, two, one. So I do 1, 1, 0. So I don't know. Solve this or this thing. Minimum number of moves. Okay, so let's say we start one, right? Actually, 0, 1, 2, 1. Okay, so let's say the first number is 1. Okay. That is 663, right? So 63. After 3, this is actually on the previous one. So this is, so you want, because if this is 163, then actually no, you do not have to go back to What is the reduction? Reason is because at 69. We have 3, 7, 10. So after 3 is 4. But it's 4 with the starting point at the previous one, or maybe the next one. So what is the difference? The parity. The parity is different, but how does it differ? Okay, so 3, yeah. But here, it's 3, 3. Starting from here, but not here. Okay. So it's this thing. That'd be great. This becomes a 4, 10 becomes I think it's more like if I think the other way around, but something like this, something weird like this. Maybe the other way around. Okay, fine. But okay, maybe not. Parity is so weird. Well, it's this part. I mean, this is maybe right, but then this also needs the parity. Something like this, but awkward. I mean, this fits. I don't know. I don't think this is right still. But I have 20 minutes left and I've done nothing for 20 minutes, so let's get another wrong answer so I can gauge of it. If it times out, that will also be funny. Okay, there we go. I mean, that's not close, but maybe it is. I mean, maybe that's not as not close as it looks. Just because you're just off by 1. And it's 15, so we start at 311. We think it takes only 6 moves, which is probably not right. 311. 3, 4, 1 is probably the answer, which is 8 moves. Why does it think that then? Yeah, because probably just thinks that 3, 2, 1 is good enough, but it's not, because it has to come back. That's where the last extra would have been helpful, but I really don't know how to do it. I'm missing something. I feel like there's something dumber for Q4 that I'm missing. Like, we have the requirement away, but I just don't know how to solve for this. Without maybe doing some stupid simulation, which is... Honestly, that's maybe what I needed to do. That's what this is, right? I'm just like off by 1 and all these things. I don't know how to do it. That's kind of silly, but okay. I know I'm having an off by 1, but I don't know how to resolve it. There is something about odd even that I'm not handling right. I'm not thinking about it right. Okay, so 3, 1, 1, right? That's the one that I'm having issues with. How many moves is that? Well, 3. Okay, you have 2 extra, so you have to at least come back. So that's 3, 3. And then 4, and then 1. Okay, well. It's not even like a decreasing thing, because three, 4, 1 is the answer, not 3 for 3, 1, 1. Right? No, maybe 3, 3, 1 actually. Actually, maybe I'm wrong. I am wrong. It's 3, 3, 1. Well, but still it's 2, it's 1 more. How do I fix it? I don't know how to fix it. I don't know. Then now this doesn't. This works for the other stuff, but not here, because I don't handle the. Oh well, this is just awkward, honestly, and hacky. I mean, even more hacky. But I'm missing some core principle. I mean, this is, I'm putting if statements because I can't figure it out, but I'm missing a core principle. Is the sum of No, but you still have to count the number of moves. You can't just guess them. I don't know. Let's see. So it starts at 1. And every even number something nutty like this, but I don't know. Maybe it's just, I don't know, I wonder if it's a knowledge thing, but 11 minutes left. I've been wasting my entire time in this thing, right? So is there a dumber DP? Do I need to reset? I feel like this is roughly right. The idea. I'm just not entering it apparently. That's the thing, like 3, 1, 1. So 1, 1, 1, 2, 2, 3, 3. I don't think. I don't even have an idea. I don't know how to, like I don't feel like I'm working towards something. That's the annoying thing. I feel like the framework is right, but I'm not getting it right, clearly. Just one of those days. Huh. And a lot of people are getting it. Having a rough patch. Is there another way of thinking about it with binary search? Maybe looking at the next number. Let's try again. Why not? Maybe I did it the wrong way. I have 8 minutes. What else I have to lose? Okay, so then now need sub I, and then once they need sub I plus 1. So delta is equal to need of I plus 1, or need of I minus 1 minus needs of I plus 1. If delta is greater than 0, then we add it by delta. Yeah. Is that it? Am I just being dumb? No, this is very well. Okay, I mean, at least I almost don't know what I want. So, okay. So then now, oh, and but then now, need of I plus 1 minus need of I minus 1. Maybe. Still wrong. Why? Four, 9, 12. So 4 moves. We go 3. Okay, 6 moves left. So then now it goes 6, 5. Oh, turns. But this is actually plus times 2 minus 1 to come back. Okay, that didn't work. Is that it? I don't know. Maybe, okay. Well, at least it's slightly closer, maybe. 5 minutes left. Not so bueno. Okay, so you have 2, 1, 16 when it should be 12. That means that my answer is too good. Right? So you have 2, 1, 1, 2. So okay, it goes to. So
So it does 3 moves and go to the next one. No requirements. This should be at least 1, right? This is very wrong. At least 0, maybe. Maybe this is also wrong, but that's actually bad though. I don't think, maybe that was that wrong? No, this is right for everything else up to here. But that means that it relies on this being negative somehow, which is actually not great. If need sub I is zero, then we just do, okay, right. Then turns, continue. Maybe it was doing some other crazy things. Yeah, still wrong, but I don't know. I mean, I feel like it's something roughly like this, but I think this is too much of a hack. Oh, actually, time limited. That's actually not great. I mean, it still might not work, but I want to at least see how Java handles it. I mean, I'm honestly still not that confident about this in general, but what a weird problem. I think I was thinking about it backwards too complicated. With a minute left, so I'm happy, but I mean, the idea I had for an hour, so it wasn't like I got too lucky, but I yeah, 5 wrong answers. But so I did a while, but I think that is the thing about I don't even know if this is quite right, honestly. Like, I wouldn't be surprised if there was a wrong answer that submits this, but oh, because this assumes that in the future you always have numbers left because there's no zero, there's no suffix 0. So I think maybe is that responsive that's right, but it's, I don't know, and time just ran out, so I don't know. But yeah, I mean, sorry friends, I didn't think Q3 was that bad, but I knew how to do Q4. I knew how to do Q3 pretty quickly. Q4, yeah, I think I just didn't think about it enough. I think again, I made the mistake of
assuming symmetry. And as soon as I did the symmetry the other way, the math and the logic makes a lot more sense with respect to someone like this. But oh. Sorry friends, I'm still just absorbing this Q4. Sorry, I'm just kind of reflecting. I mean, Q1, Q2, Q3 is fine, but yeah, I'm happy about. I didn't expect it to be time limited though, honestly. But why is that? Is Java? I mean, is Java that much faster? Excuse me. Excuse me. I mean, maybe it's the allocation of space. We can just say okay, right? No, I mean, we don't need it, but it just makes it so much easier. I don't know how to speed this up in Python, actually. Oh, I guess we can kind of cheat now, right? I mean, I kind of solved it. I mean, Q4, I kind of knew it was, yeah. I mean, this is basically what we're doing. Some parts of it, anyway. If it's less, then you take one step, otherwise. Yeah, I think this is exactly what we're doing, I suppose. Okay. Good job, Larry. Kind of crazy how easy it is to make a silly mistake. Okay. Anyway, yeah, that's all I have for this one. That's all I have for this contest. Thanks for watching. Got another last minute save. That's why you don't give up. But yeah, thanks for watching. Stay good, stay healthy, take your mental health. I'll see y'all later and take care. Bye bye.